we're going to look at solving inequalities. Okay, so far what we've been doing is we've been solving equations. So if we say like 2x is equal to 8, and we divide both sides by 2, we get x equals 4. That is a single, that's one solution. That's the one number that'll make this statement true, and it's the only number that'll make it true. And usually when we're solving equalities, there's usually just a single set solution. There's one number that makes that work. But when we start looking at inequalities, if we start looking at x is, let's say, less than 4, well, there's not just one number less than 4. They're technically an infinite number, or let's say infinitely many. They're an infinite number of terms that are less than 4. 3, 2, 1, 0, -1. We've got fractions, we've got decimals. There are an infinite number of solutions that fit this type. So while a lot of the work is going to be very, very similar when we're solving inequalities, what's going to change is how we write our final answer. So we're going to look at, there are 4 possible cases when we're talking about inequalities. So this is the symbol for less than. This is the symbol for greater than. This is less than or equal to. And it's greater than or equal to. So this right here is just an inequality notation, kind of just the standard one with an inequality. There are 2 other ways we can represent the exact same type of solution. The first is with a graph. And these are just literally just a very, very simple graph on the number line. So here we're looking at the number 4. And the way to kind of think about this here is that since x is less than, that means it's smaller. And if we're talking about the number line, smaller numbers are going to be on the left-hand side. So that means that we're going to draw a line going to the left. Now, since we're strictly less than 4, we're not including 4, but we're including things like, technically, if I have like 3.99999 going on infinitely, that's technically part of this set. And I don't have to try and measure my line so I get infinitely close to 4. So the way we'll denote this is if we're not including 4, but we're going right up to it, we will put an open circle there. And that open circle means we're not including 4, but everything just below 4 is part of this graph as part of my solution set. Questions on that, anybody? Okay, so if we just look through what the rest of these graphs look like. Here, x is bigger, it's greater than, so that means that my numbers are going to be going to the right. That's where bigger numbers are. And just like before, since it's strictly greater than, we're not including 4 in this case. So that's going to be an open circle. All right. Here, once again, we're at 4. We want numbers that are smaller, so that's going to be going down to the left. And here, since we are including it, since it's less than or equal to, we're including 4, so that's going to be a closed circle. And likewise on our last set, we're still at 4. We want the numbers that are bigger, so bigger goes to the right. And since we're have that equals to, that means that we have a closed circle there. So these would be the graph notations for each one of these inequalities. Okay. Any questions on this?
So graph notations, pretty much.
Yeah, these are the 4. I mean, for these are the 4 possible combinations of graph notations that you can kind of have for these types of problems.
Oh, okay.
Yeah, this is what we call a graph. Well, yeah, I'll kind of slide this down. This is what we'll call the graph notation. This is technically called the inequality notation. Slide this down a little bit. Okay, so the last set, and the last way we can represent our answers, is with something that we call an interval. And an interval is going to be 2 things. It's going to say, where do we start? And where do we end? And it can either have parentheses if we are not including those points, if we're not equaling those values, or it could have brackets if we do equal or if we do include those points. But for the most part, you're just saying, where does your line start? Where does your line end? And the way you read it is we go from left to right. So I'm just going to copy down this little picture right here. Technically the same one from before. You don't have to necessarily do this, but just so in the notes, it's very clear that what I'm referencing. So in this example, once again, the number 4 is either going to be the start or it's going to be the end. And if we're reading this from left to right, it's going to be the end of my line. And this arrow means that we keep going. So technically speaking, what's at the beginning and end of each one of these lines is, well, on the left-hand side, we have negative infinity. And on the right-hand side, we have positive infinity. So this arrow means that we keep going down in this direction. So that means that this thing is going to go to negative infinity. And since it's an open point, that means we are not equaling that point. So we're going to put a parenthesis there. And we can never equal infinity, so all infinities are always going to get a parenthesis. So here we have an interval notation. Questions on this so far?
Yeah.
Go ahead.
When do we put a bracket if it's thing?
So if the bracket will be when we have closed points.
Closed, okay.
So let's jump to that one. We'll go straight to that one. So when we had this example here of 4 with a closed point going to the right. So once again, breaking it down in terms of a start and an end. If we're reading this from left to right, 4 is where it starts, and it's going to end at positive infinity. Since we have a close point on 4, that will be a bracket. But we can never equal infinity, so infinities will always get a parenthesis. Okay, so we'll kind of do the other two, just to kind of finish the full set off. We have open circle going to the right and closed circle going to the left. So once again, I'm just going for the first couple examples, I'm just going to put in the infinities here so you can kind of see where these are going. These are not really mandatory, but if they help, they help. So here, once again, reading this from left to right, 4 is the start, and it's going to the right, so that's positive infinity. We have an open circle at 4, which means we have a parenthesis. And infinity always gets a parenthesis. On this last one, if we're reading this from left to right, 4 is going to be the end of my line. And we're going down to the left, so we're going towards negative infinity. Infinities always get a parenthesis, and since 4 has a closed point on it, it's going to get a bracket. Okay. Questions on this? Okay, so for the most part, if you can follow, like I said, this is all after we finally solve the equation. There is the inequality notation, the graph notation, and the interval notation. And their homework will always make it very clear which one of the forms it wants. Usually the two you're going to be dealing with the most is you're going to be doing the graph and the interval. But for the most part, once you have this kind of setup down, the solving outside of one rule, which we'll cover in just 1 second, a lot of the solving is going to work exactly the same. So let's do an example. I'm just going to do this down here. Okay. So here we have 3x plus 6 is greater than negative 21. So before we get to any graphing or doing any sort of interval notation, what we always want to do is, just like before, solve for x. So the first step is going to be I'm going to subtract the 6 over. So negative 21 minus 6 gives me negative 27. And if we divide by 3, that's going to give me x is greater than negative 9. Okay, so in terms of the graph, here's negative 9. X is the bigger value, so that means that we are going to go to the right. And since we're not equals to, that means that we're not including 9, so we have an open circle there. So there's the graph. And in terms of the interval, well, we started off at negative 9. The two sides to my number line are negative infinity and positive infinity. The arrow is going towards positive infinity. 9 is an open point, so that's going to be a parenthesis. And infinities always get parentheses. So given this equation, we have a graph solution and an interval solution. Okay, are there any questions on this?
Yeah, one.
Go ahead.
Does the symbol ever change? The greater than? Does it ever change?
It can, and that's going to be the other rule.
Yeah.
So yeah, this can sometimes change direction inside of a problem. And we'll get to that in just one. We'll get to that in just 1 second.
Just curious, you know.
Yeah, no, sure. That's a good question. How are you going to trick me? How are you going to make this harder? It's already. This seems. I'm kind of understanding it. How are you going to screw me later? Yeah. So the rule and how this can change. I'll write it. Let me go down here. It is as follows. Oops. If you multiply or divide by a negative number, the inequality will change directions. So in this case, that didn't happen because we divided by a +3, so the inequality stayed going the same direction. But let's do just kind of a different example. Yeah, let's make this a -6. Okay, so working this one out. There are a lot of ways you can go about this, but I really want to illustrate how this rule works. So I'm going to go a very specific way, which is I'm going to subtract over the 4x. Which is going to give me 6 is greater than or equal to -6x minus 4x will give me -10x plus 10. And then I'm going to subtract over the 10. So what that's going to give us is -4 is greater than or equal to -10x. So solving like we normally would, we're going to divide both sides by a -10. And because we're dividing by a negative symbol, that's going to change the direction of the inequality. So this is now going to become a less than or equal to. Negative is going to make that a positive, and 4 over 10 simplifies down to be 2/5. And then here on the right-hand side, we just have x. So there we have the inequality notation. If we want to draw this as a graph, here's 2/5. Since x is bigger, we're going to be going to the right. And we have a equals 2, so that's going to be a close point. There's my graph. And in terms of an interval, reading this from left to right, 2/5 is where we start. We're going to the right, so that's positive infinity. Infinities always get a parenthesis, and here 2/5 we'll get a bracket. Okay. Any questions on this?
The 2/5, you divided it from 4 and 10, right?
Yeah, just simplify down. Pull the
Okay.
2 out of both.
And you
Yeah.
change the symbol. Okay.
Yeah, because we had a negative over negative gave us a positive.
Yeah.
And since we divided by a negative number, we changed the direction of the inequality.
Okay, so change the symbol if it is negative or positive. I see. Okay.
Mhm. Okay, any other questions on this? All right, I want to do an example on the homework just to kind of walk you through that because it's a little different. Or it's not different, just you have to kind of know how to input this stuff into the homework. So I'm going to do literally a homework question. So it's a pretty easy one to kind of start off with, but I just kind of want to show you how this goes. That's not what I wanted. That and the annotate. Okay, so we're solving this inequality. It's a very easy solve here. 12z is greater than 96. So, I mean, all we have to do here is just divide, right? So that's going to give us that z is greater than 96 over 12 is 8. So thinking about the graph here, there are going to be two pieces, which is whether it's an open point or a closed point. And in this case, since we're not equals to, we're going to be an open point at positive 8. Oops. Open point at positive 8. And then we have to figure out what direction are we going. So since z is bigger than 8, we're going to draw this bigger, which means to the right. So what you're going to do is you're going to click the line and then just click and drag. And eventually, if you keep moving it to the right, the computer will know that you mean that you want a little arrow there and it'll draw. You want to keep drawing until you hit that arrow. So that's how you do the graph in the homework. The other thing we want to talk about is we'll kind of just talk about this by hand real quick. So once again, where's my, just kind of writing this out. So once again, we have the line of 8 and we're going open circle to the right. So in terms of an interval, that would be 8, comma, we're heading to the right, infinity, and then parenthesis, parenthesis. Alrighty. So how do you do, I mean, a lot of this is pretty easy. How do you do infinities and whatnot? Now, there are two ways to do this. You can type this all out just with the keyboard because the parenthesis is shift 9. So you go 8, comma. The way you do an infinity is if you press the letter O twice. Your computer is smart enough, the program is smart enough to recognize that you want an infinity. So you just do lowercase o twice and then right parentheses. So you can just literally type it in. Or the other thing you can do is you have this thing here for intervals. And if you click that, what you can just do is, well, we've got double parentheses. So you'll click that one. And you'll do 8, comma. And then there's your infinity symbol right there. So that way, if you forget how to type these things in, if you click the interval, you can just literally build your interval by just clicking on stuff, which is kind of nice, especially if you're on like a tablet or something where the keyboard is maybe a little bit hard to get to. Some of the math numbers and parentheses can be hard to get to if you're on like a tablet, if you're doing this on your phone or something. So this is kind of a little easy way. You just click the box and that'll bring up kind of this input thing. And then you just go over to interval and then choose the intervals that you need. Okay. So here's how you work one of these out on the homework. Any questions on that? Alrighty. So we're going to do a couple more examples. So there are another thing we can kind of talk about. Let's see, let me clear my drawings. There we go. What are called compound inequalities. And really, actually, let me move this over. Really, what compound inequalities are equalities that work on both sides. So an example of this would be like if we have x is less than or equal to 10, and that is less than or equal to 4, like so. So this is a compound inequality. It's technically two inequalities. This is saying that this first one is saying that 4, well, x is bigger than 4. And it's also saying that x is less than or equal to 10. Really, what we're saying here is that it's in between these two numbers. So as a picture, what these compound inequalities look like is we've got, technically it's an equal to, so a closed point at 4, we're equal to, so a closed point at 10, and it's just the points in between. So in this case, we would have an interval of 4 comma 10 because it starts on the left at 4, it ends on the right at 10, and we just put our little brackets because these are both close points. Okay. So really, anytime we see these compound inequalities, really just like physically x is in between the two numbers, that's also what's happening on the graph, is that we're drawing a line in between these two numbers. Now, sometimes there's a little bit of an equation that we need to solve. So we could have something like this. So that should be negative 10. So when we have like this, what we're going to do is we're going to get x by itself, but instead of talking about the left and right, we have like the left, the middle, and the right. And the goal with these compound inequalities is going to be able to get that variable by itself. So what we're usually going to do is we're going to do something to the middle. So in this case, I'm going to subtract the 2 from the middle. And instead of just mirroring it on the left-hand side, we're going to have to mirror it on both the left-hand side and the right-hand side. So we kind of do one operation in the middle, and then we apply that to the outer interval numbers, or sorry, outer inequality numbers, I should say. So here, if we work this out, negative 10 minus 12 gives us negative 10 minus 2 gives us negative 12 is what I meant to say. And 11 minus 2 gives us 9. Okay, and then for the last step, we're just going to divide by 3. Whatever we do to the middle, we're going to do to the left-hand side. We're going to do to the right-hand side. Just put a prompt here. Okay. So on the left-hand side, negative 12 over 3 gives us negative 4. Is less than or equal to, here they cancel out, we're just left with x, which is less than or equal to 9 divided by 3 is 3. So, in terms of a graph, we have -4 on the left, 3 on the right. These are technically both closed points, so I'm going to put closed points there, and the graph is just going to be in between those two numbers. So in terms of the interval, we're going to have -4, +3, and since they're both closed points, we're going to bracket each one of them. Okay. Any questions on this? Okay.
Actually,
Go ahead.
back to 3x plus 2. You just minus those?
Correct. Just like, because imagine if this hadn't been here, right?
Yeah.
Your first
Just
step
the-
would have been to subtract over the 2, right?
Mhm.
So what we're just doing is we're doing this kind of on both sides. We're doing it here on the right-hand side, and then likewise, if this had not been here, you would have subtracted the 2 and then moved that over to the left-hand side. So we're just working all the sides at the same time.
Oh,
Someone asked what happens if one of them has an equals 2, but the other one doesn't. So let's say we change this one. Let's say that one didn't have an equals 2. That's fine. That means that we're just going to put an open circle on that one and then connect it that way. And then that would just lead to a parenthesis on that point. So if the only thing the equals to does is it changes whether it's open or closed and whether we have a parenthesis or a bracket. In terms of what the number is and how you solve it, those all stay exactly the same. The only thing the equals to changes is whether it's open versus closed and whether it's bracket versus parenthesis. So that's the only difference.
Okay.
Okay, so I'm kind of pull that back to what it was. These are both bracketed. We'll do an example. The next example, I'll do it where one side has it, the other side doesn't. It doesn't really change much up until literally the very, very last step of the problem. Okay, any more questions on this one? Okay, let's do one more. Let's get some fractions in the mix. I said I was going to do one. Let's go on the left-hand side. Okay, so the first thing we have to do is we have to get rid of this denominator. So since we're dividing by 4, the way we get rid of that is we're going to multiply everything through by a factor of 4. So on the left-hand side, 4 times 5 gives me 20. Is less than here. The 4 and the 4 will just cancel each other out. So we're left with 2x minus 8. And then we have less than or equal to 4 times 9 gives us 36. Okay, so now that we've gotten rid of the fraction, we're going to do exactly the same thing we did last time, which is we're going to work from the middle outward. So first thing we want to do is get rid of this -8. So I'm going to add 8 to both sides. So on the left-hand side, that gives me 28 is less than 2x, which is less than or equal to 36 plus 8 is 44. And then we're just going to go through and divide everything through by 2. So 28 divided by 2 gives us 14 is less than x. And because the 2 and 2's cancel. And 44 divided by 2 leaves us with 22. Okay, so there we have the inequality notation. In terms of a graph, we're going between 14 and 22. Since we're not equal to here, that's going to be an open circle. Since we are equal to on the 22, that's going to be a closed circle. And x is in between, so that means that my line is just going to go in between them. And then for the interval, we start at 14, we end at 22, and we have a open circle on 14, so that's a parenthesis, and a closed circle on 22. So that's a bracket. All right, so there is one that had a compound inequality with fractions involved, and even then, not too terrible, because we were able to get rid of the fractions. We get rid of the fractions on the first line, and then it's just back to our regular algebra steps. Okay. Any questions on this? Okay, we're probably gonna go the full amount of time today. So in that case, I usually like to give a little 10-minute break right around the 6 o'clock mark. People to go get up, use the restroom, go call a loved one, go do a shot of whiskey if you needed to get through the rest of class, whatever. I'm gonna go grab some more water. You do you. But right now I have 5:58. Let's be back at 6:08. So 10 minutes. I'm going to stop the recording right now. Or I'm going to pause the recording. I'm just going to step out, grab some more water, and I will be right back. See you in about 10 minutes. All right, everyone, welcome back. Sure, I'm on the right chair. Yeah, we're all good. Okay, our last section for today is going to be compound set operations. And we were talking a little about compound inequalities. This is actually very much related to that, and we'll get into that in just a little bit. But really, in general, when we talk about an operation, we're talking about something that combines things. Addition is an operation, subtraction, division. If you square a number, that's an operation. The two operations we're going to look at are and or. So also sometimes the and is also what's called the union. That was nicer. No, pardon me. I have that backwards. And is what is called the intersection. Pardon me. Or is what we call the union. Okay, so we're just going to look at a quick example here we're going to look at two sets. We'll look at the set A, which is 1, 2, 3, 4, and B, which is the set of numbers of 2, 4, and 6. So if we talk about A and B, and sometimes this is written as A and the symbol here, this upside down U, it's called the intersection. What we're looking for, and these mean the exact same thing, this is just kind of the word, this is the symbol for it. What we're looking for is elements that are in both at the same time. It's in both A and B. So in this case, we're looking to see what they have in common, right? So that would be they both have a 2 in common. They both have a 4 in common. So for the intersection, or A and B, is 2, 4. So that's the and, or the intersection. If we talk about or, what's in A or B, or the way we write this is with a symbol AUB, where U stands for union. What this represents is we're kind of combining them together. It doesn't have to be in both of them. It just has to be in either A or B. It's in one of the two. So really what that means is we are just going to take these two sets, A and B, and we're going to put everything into one large set. So you could just write this literally like left to right, which is, 1, 2, 3, 4. And then we've already covered 2 and we've already covered 4, so we don't need to rewrite those in there. So the only new number we're going to add in would be 6. So that would be the union. We're joining all of the individual numbers into one big set. And these are the two operations we're going to look at today, or in this section, I should say. The and, the intersection, or the union. Questions on either one of these? Okay, so kind of in general, when we're talking about the intersection, we're kind of looking for that common overlap. And with the union, what we're kind of doing is we're kind of merging everything together. I'll write that one nice. So we're going to apply this idea to inequalities. So what we're usually going to do with, or how I'm going to work these out, you could do it all if you can do it all in your head, that's great. But for the most part, I like to do these. I'm going to color code these as two separate lines, and we're going to talk about how we're going to combine them, or what's going to come out of this operation. Okay, so just drawing these out in blue, we've got the numbers 1 and 4. So 4 we're equals to, so that's closed. And x is smaller than 4, so that means those numbers are going to the left. And in red, we're at -1. We're equals to, so we're at a close point. And since x is bigger, we're going to the right. All right, so we're looking for the and. This is that and intersection. Really what we're looking for here is, where do these two pieces overlap? And you can kind of just eyeball it here. We have this overlap going between 1. So we'll try that again. 1 and 4. This is that overlapping area. This is the area that's on both lines that they have in common. So that's going to be the solution. That's what my graph is going to look like when we do the AND operation. So we're going to go just between these two numbers because that's where they overlap. So we have a closed point at 1, a closed point at 4, and it's just this area in between. And you'll notice that this picture kind of looks similar. We were doing things like this. Oh, sorry, that should have been, pardon me. That should have been a -1, pardon me. My little negative symbol there. We had these when we had something that looked like this. -1 is less than x is less than or equal to 4. That would also give us that same picture. And like I said before, this is technically 2 inequalities. It's the first one, -1 is less than or equal to x, and it's the second one, x is less than or equal to 4. So this compound, kind of we smush this together, happens with these AND type inequalities, kind of merging them together to give us that common thing. We're not going to do too much. Usually they're either going to be listed as, a lot of your homework problems are going to be listed as either this form, and we're going to work with it in that form, or this form. Next week, we're actually going to have to translate in between these two, but we'll save that for next week. But just kind of talking about how I used the word compound in the last section. This is why. This AND gives us the exact same thing, something equivalent to this kind of two-way inequality we looked at earlier. Okay. Are there any questions on this?
I have a question.
Go ahead.
So pretty much, when you see least to greatest, you do the opposite. You draw a line the opposite way.
Well, no, it's not necessarily the opposite. The way I look at this is, so there's always this idea of bigger or smaller, right? So if I'm looking at the blue line here, x is smaller than 4, right?
Mm-hmm.
So smaller means we go towards the left.
Oh, I see. Okay.
Whereas here, x is greater than or equal to -1, so x is bigger. So if I go bigger, that means we go towards the right. The reason why I do that is because I can switch the order here, and I could say -1 is less than or equal to x. I've technically changed what type of inequality we have, right? But in this case, x is still bigger than -1, so this would still have the exact same picture. Even though x and -1 are on opposite sides and I change the inequality, these two things are the same numbers.
Oh, okay.
Does that make sense?
Same numbers. Okay.
So what I'll tend to do is, instead of saying like, oh, greater than always means left, I tend to look at which side is x on. Is it on the bigger side or is it on the smaller side? In blue, x is on the smaller side because the inequality is facing away from it. So smaller means we go to the left. In red, the inequality is facing towards it, which means it's bigger. Bigger means we go towards the right.
Okay.
That make sense?
Let's say, yeah. Is the
Great.
number.
Someone has to do another one. Sure. Let's look at x is greater than 4. Or greater than or equal to 4. And x is greater than or equal to -1. Oops. Okay, so what do we got? -1, +4. Once again, let me not do, I use 4 too much. I think I use -1, yeah. Let me change some numbers up here. I don't know. It really doesn't matter what these numbers are, as you'll see. Like, it doesn't actually change any of the calculations, but just so we have something different. Okay, so let's do another one. Once again, I like to draw them individually first. So we have x is greater than or equal to 5. So the greater than equal to means we've got a closed point. And x is bigger, so that means we're going to the right. Second one, we're doing in red. We have a equals 2, so we still have a closed point at 2. And x is bigger, so this one's also going. Oops, okay, let me try that. I mean, it doesn't, I'm going to try my best to draw a horizontal line that long. Let's see. Third time's the charm. That's better. It's not great, but it's better. Okay, so in this case, once again, what does the and mean? We're looking for where is their overlap? Where do these things both have lines? And that happens starting right here at 5, and it continues all the way down to the right. These guys are going to overlap everything past 5. So the solution as a graph would just be starting at 5, looking at the overlap here, would just be going to the right. Okay. Questions on this one?
Yeah, I got one.
Go ahead.
When you were writing it down, this is off topic a bit. So when you were writing something down, I could have sworn you just turned off, and I'm like, you just
I turned off. What do you mean I turned
like
off?
when you were writing something, like I could have sworn your screen was frozen for a second. I could have sworn that what happened, but like,
Well, okay. As I'm drawing this, is that showing up?
yeah, sure. Thank you.
Okay. Double check. I might have just been a momentary lapse in internet. I'm not sure.
I didn't see anything else, so you're good.
Okay, great. If anyone is anyone else having if anyone else is having issues with that, please just sound up in chat so I can see if it's on my end, or it could just be might be the internet on your end. That's the one thing we never really know whose computer is screwing up right now. Could be mine, could be yours, who knows. Okay. So these ones were already solved. Sometimes we do have to do a little bit of algebra in terms of solving these to get them into this form. So let's do one more of these and problems. Actually, we're going to do 2 more and problems. So we have 5x minus 1 is less than or equal to negative 21. And once again, we're going to be solving this. And negative 3x minus 2 is greater than 5. And you know what? I should have done this for the last problem. Just to really nail it down. Let's also just do an interval for this one. So we're starting this off at 5 and going towards positive infinity. And that's going to be a parenthesis here, and 5 is a closed point, so that's going to be a bracket there. Just to kind of say we did. Okay, so when it comes to these cases, really what I'm just going to do is I'm going to solve each one of these separately, and then eventually we're going to get it down to these stages here where they're solved, and then we'll just do a little graph at the end. Okay, so solving this one for x, first step is I'm going to add the 1 over. So we have 5x is less than or equal to negative 20. And then we're going to divide the 5. And we have x is less than or equal to negative 4. All right, so that's the first one. I'll do this one on the right-hand side in red. So I'm going to add over the 2. So we have negative 3x is greater than 7. And we're going to divide by a negative, and remember that changes the direction of the inequality. So that's going to give me x is less than negative 7 over 3. Okay, so we want to put these on the number line. If you're not sure where a number is, like, I don't know, where is negative 7/3 compared to 4? Just very quickly throw that into your calculator. Negative 7/3 is about negative 2.3. And that just kind of helps you know where to place this stuff. So negative 4 should be on the left-hand side, and negative 7/3 should be on the right-hand side. Okay. So working this one out in blue first, we're at negative 4. We're equals to, so we're closed. And x is smaller, so we're moving to the left. Over here, x is less than negative 7/3. So we are open because it's just strictly less than, oops, wrong color. Open since we're strictly less than, and since x is smaller, that means we're going to the left. And since we're doing this as an and, once again, we're looking for where do they overlap? And that overlap happens right here, and then it goes down to the left. So the final solution as a graph is going to be a closed circle at 4. Oops, wrong color. I want to do purple because we're doing the overlap. And then we're going down. That would be the and of these two. So as an interval, this would be from negative infinity to negative 4, bracket, and parenthesis on the infinity. So we kind of zoom out just a little bit so I can get the whole problem on here. Leave that up for a second for people writing it down. Any questions on this example here? Okay. We're going to do one more and problem, then we'll start talking about the or problems. For the and problems, there's one more case to kind of look at. We'll do kind of just a simple one in terms of the actual solving. Okay. So once again, just like the last example, first we're going to solve these down separately, graph them, and since we're doing an and, we're going to see where do they overlap. Okay, so working off this first one in blue. So first step is we want to subtract the 5 over. So we have 3x is less than negative 3. And then divide both sides by 3. And we have x is less than negative 1. On the right-hand side. We have x minus 10 is greater than 12. So we're just going to add the 10 over. And we have that x is greater than 22. All right, so in blue, we're at -1. We're strictly less than, so that's an open circle. And we want x to be smaller, so that is to the left. In red, we're at 22. No equality means that we're still open circle, and x is bigger, so we're heading to the right. So the and means we're looking for where is the overlap. And in this case, these lines don't overlap at all. One goes to the left, one goes to the right. They don't have any common area. So this would be a case where your answer would be does not exist, or what you'll usually type in, well, actually, I'll say that the answer here is DNE, which is short for does not exist. So there are times when you have these and problems where there is no overlap between. So when it comes, if you're asked to draw a graph of it, you would just leave your graph line just totally blank. And then for the interval, you would just type in DNE. Okay. So this is kind of this special case here. And this only happens with the and. When we do the ors don't have a do not exist case. We'll kind of talk about that in just 1 second. Okay, questions on this one before we go to the or operation? All right, so one more time, just to reiterate, the or, which is also sometimes called the union, is where we're going to merge these two things together. So if we have something like x is greater than 4, or x is greater than or equal to -2. We're still going to start this off the same way, which is by throwing these on the number line. Oops, 4. And then we're going to color code these and draw them on the graph. So at -2, doing this one in red, we're equals to, so that's a closed point. And x is bigger, so we're going to the right. At 4, we're an open point. And since x is bigger, we're also going to the right. So the or the union means that we're merging these two lines together. So we can kind of think as, you've got these two lines on top of each other. We're kind of just sliding them into one big line and what that line would look like. So we're not just talking about the overlap, we're talking about combining everything together into one continuous line. If you kind of did that and kind of merged the blue line into the red line, that would be one long line starting at -2 and just going all the way down to the right. So then the interval for this guy would just be -2 to infinity. And we'll have a parenthesis here and a bracket there. There's my interval for this one. Okay. Questions on the and, or sorry, questions on the or problem here.
So,
Go ahead.
so the only ors merged together. That's it.
Yeah, an or just means that we're merging the two things together.
Okay. Thank you.
You're welcome. All right, we're going to do a couple more of these. Let's actually do one where we need to do a little bit of algebra. Oh, sorry, that should have been a minus. Pardon me, that was right. I had it right the first time. Should have been a minus here. Yeah, that's right. That's right. Okay, so this is just going to be an or, where we need to do a little bit of algebra to solve these out. Okay, so once again, I'm just going to color code these. Work these on out. So my first step here is first thing I'm going to do is I'm going to subtract over the 5. So we have negative 2x is greater than or equal to 11 minus 5 gives me 6. We're going to divide, but since it's a negative, we need to change the direction of the inequality. So that's going to be x is less than or equal to negative 3. In red, first step, we're going to add the 7. So that's going to give me 4x is greater than or equal to negative 27 plus 7 gives me negative 20. So if we divide through by 4, that's going to give me x is greater than or equal to negative 5. Oops. Didn't keep my code. X is greater than or equal to negative 5. All right. So we got negative 5, negative 3. So let's draw this one in blue first. We have a closed point. And since x is smaller, smaller means we're going to the left. Now we can draw that out a little farther. In red, here we have closed point at negative 5. And since x is bigger, that means we're going to the right. Okay, so now we're going to apply the actual operation. We're doing an OR operation, which means we're going to merge these into like one big line. So once again, if you kind of think about just squishing these together into one big line, well, that would be one big line that goes all the way to the left and all the way to the right. Right? If we just combine these into one big line, that would just be one very long horizontal line. Let me try and draw that a little bit nicer. Just one very long horizontal line. And since we go through these points and we keep going, the actual interval for this is going to be from negative infinity to positive infinity. Okay. Let me zoom out one level. So here is another OR type problem where we're just combining these two into one large line. Okay. Any questions on this one? Or move on to the next one. Okay. So last problem we're going to do today. It's going to look like something we previously said. It's going to look like a previous problem, but we're going to treat this a little differently because it's an OR type case. So let's kind of work that out. Took this first one, or okie doke. So just like before, we're going to solve these two independently of one another and then combine them together using an OR operation. Okay, so working the first one out in blue. First step is I'm going to add over the 4. That's going to give me 2x is less than 5. And then we'll just divide out the 2. So we have x is less than 5/2. On the right-hand side, in red, we're just going to subtract over the 1. So that's going to give me x is greater than 5. So if we throw these on a number line, technically 5/2, if you turn that into a decimal, that's 2.5. So that means that that guy's on the left-hand side. And 5 is on the right. Okay, so graphing this one in blue, we have an open circle. In blue, we have an open circle. And since x is smaller, we're going to the left. And on the right-hand side, we also have an open circle at 5. And since x is bigger, we're going to the right. Okay, so last time when we had this type of thing happen, we were dealing with an and, where we were looking for an overlap. And there's no overlap here, so that was a DNE, a does not exist case. Here, we're not looking for the overlap. Since we're doing this as an OR, we're just talking about joining them as like one big solid line. Well, the problem is that they don't really combine very well, but we can still talk about them as just one solid set. It's just that the picture is going to be the exact same thing. There's no real combining. It's just going to be the two lines in one single color. We're just going to have the one line going to the left and the one line going to the right. And that's okay. That sometimes happens with these union problems. There's no, oops, back that up. There's no combining to do, so you're just left with the lines you started off with. And this is specifically because we're dealing with an OR. We're dealing with a union. The question comes, however, how do we actually write this purple line as an interval? And the answer is you can't write it as just one interval. We've got this big gap in between, and we have to denote that gap somehow. So really what we do for this is we're going to do the first line as an interval by itself. So this first line on the left would go from -infinity to 5/2. Sorry, we'll get to that in just one second. And then the line to the right would have an interval from 5 to infinity. And the way we denote the gap is that we're just going to say that we're unioning these two sets. So that's where that union comes in. We're actually going to do the symbol U, which you just type in your homework, is just type in the letter U. So this is kind of one of those cases, and this also really kind of illustrates the importance. There's a big difference between the and version and the or version. Which verb we use is important because that changes how we look at a particular graph. Are there any questions on this one?